In this video, I will provide an overview of HAProxy load balancing algorithm. Focus on two main types: dynamic and static load balancing algorithm. Dynamic load balancing algorithm make decisions based on the current demand on the server side, but static load balancing algorithm remained fixed regardless of the incoming traffic or server status. There are two main types of dynamic load balancing algorithm, but I believe leastconn is more suitable to describe dynamic load balancing algorithm. So let's go and see what is the dynamic load balancing algorithm. Imagine we have an HAProxy which reversing all incoming traffic to the backend server, and we have three backend servers. One has 20 established connection, second one processing 10 requests, and the third server has 15 requests to process. The new incoming traffic will redirect to this server because it has least connection to process. This load balancing algorithm is suitable for services like LDAP, SQL, or TSE, and it is not recommended for HTTP service. It allows on-fly change on wait, and it's not required to restart HAProxy after changing wait in HAProxy. If you don't know what is the wait and how can we change wait, see my video about wait in HAProxy services. Roundrobin is another dynamic load balancing algorithm. Imagine we have a HAProxy service here, and incoming traffic from the front end is redistributing to the backend. Roundrobin is fair and redistribute incoming traffic to all backend servers equally. Roundrobin is dynamic load balancing algorithm, and on-fly change will affect on the current server status. Now let's discuss a static load balancing algorithm. Static RR is same as round robin. It is a static round robin, but it is a static load balancing algorithm, and on-fly changes won't affect on the current status of the service, and it always reintroduce the failed back server to the active server pool. Imagine we have an HAProxy server, and we have different kind of backend server. We have two servers which is active and running, but this server had failed. After correcting and finding the problem, we solve the problem and turn on this server. In this situation, HAProxy immediately redirect incoming traffic to this server because it's static, and immediately reintroduce failed server to the active pool. Regarding the first load balancing algorithm, imagine we are using imagine we have an HAProxy and we are using AWS cloud as our infrastructure, and HAProxy is redirecting incoming traffic to the backend server, and we have different backend server. We prefer to put this server off till this server become at full capacity. After that, we will turn on this server and continue this process. This algorithm combined with leastconn to ensure what is the maximum connection request for the first server, second one, and the third one. Next algorithm is, and we have source as another load balancing algorithm. Imagine it is our HAProxy and we have different kind of front end and back end. Our client has different IP address. For example, this one is 1.2.1.3 and 1.4. Source load balancing algorithm create a hash based on the client IP address and make sure always this hash is connected to the same server. Lastly, we have URI. URI creates a hash based on the, this is the URI combined of host and path. When we use URI as our load balancing algorithm, our HAProxy server will create a hash based on the requested URI and always send this request to the same server. For example, if we have different kind of URI, imagine we can say it's asking for IP port, imagine it is 11 on port 80 and asking for image. Another request is asking for example movie. This URI algorithm make sure these will always go to the same server, and also this URI, this hash which created base URI always go to the same server. Also, there are other load balancing algorithms. We will test them and use in the following video.